If O is the center of the circle, then OC is the radius. AB is the diameter. Line 1 is a line that is tangent to a circle. It is always perpendicular to the radius. Line 2 is a second line. And finally, line 3 is a chord or a segment joining 2 points on a circle. Let R be the radius of the circle. Then the area of the circle can be found by the following formula: pi times r squared. And the circumference can be found by the following formula: 2 times pi times r. The central angle AOB, theta, is equal to the degree measure of arc AB. This is arc AB. An arc is a piece of the circumference of a circle. The ratio of the length of arc AB to the circumference of the circle, twice pi times the radius, is the ratio of theta to 360. Solving for the length of arc AB, it can be calculated by the following formula: theta over 360 times the circumference of the circle. Now, for the question shown below, the circle with center O has a radius 5. What is the measure of the minor arc AB, and what is the area of circular sector AOB? So, for the length of minor arc AB, we can use a formula. This is 60 degrees divided by 360 times the circumference of the circle. Remember that the radius is 5. Twice pi times the radius. Here we can cancel this one and this one. 6 here. Again, this one and this one. 3 here. Finally, the length of arc AB is 5/3 pi. Now, we need to find the area of the circular sector AOB. The circular sector AOB is this figure. So, which of the following represents the area of circular sector AOB? So here we get the following: the ratio of the circular sector AOB to the area of the circle, pi times the radius squared, is equal to 60 degrees over 360. Solving for the area of the circular sector AOB, this is, remember that here we can cancel this one and this one. 6 here. So now this is 1/6 times the area of the circle, pi times 5 squared. Finally, the area of the circular sector AOB is 25/6 times pi. An inscribed angle is an angle whose vertex is on the circle and sides are chords of the circle, chord CA and chord CB. If an inscribed angle and a central angle intersect the circle at the same points, A and point B, then the degree measure of the inscribed angle is half of the central angle. Beta is half of theta. For the example shown below, if AC is the diameter of the circle with center O, what is the measure of angle CBA and the triangle ABC? Well, first of all, if AC is a diameter, what's the measure of angle AOC? Since a diameter is a straight line, then the measure of angle AOC is 180. Now, angle AOC is a central angle, and angle CBA is an ascribed angle, and both intersect at the same points. Therefore, the measure of angle B is equal to half of the measure of 180. Finally, the measure of angle B is 90 degrees.